Today, we are going to design a password lock system built using the PIC16F877A microcontroller. This system allows a user to enter a password through a keypad, gives feedback using an LCD, and controls a lock using a relay. If the correct password is entered, access is granted. If not, the system makes it very clear that you are not welcome. The brain of the entire system is the PIC16F877A. It reads inputs from the keypad, processes the logic in a software, and controls the outputs like the LCD, LEDs, buzzer, and relay. The LCD is connected in 4-bit mode to port B. The register select pin is connected to RB0, the enable pin to RB1, and the data lines D4 to D7 are connected from RB2 to RB5. The read/write pin of the LCD is grounded, the contrast pin is connected to a potentiometer, and the LCD is powered with 5 volts. Using 4-bit mode save as pins while still allowing full communication with the display. Because port B is already used by the LCD, the keypad is connected entirely to port D. The keypad is a 4x4 matrix, which means it has 4 rows and 4 columns. The rows are connected to RD0, RD1, RD2, and RD3. The columns are connected to RD4, RD5, RD6, and RD7. Each column line has a 10 kilo ohm pull-up resistor connected to 5 volts. These pull-ups are very important because they keep the column pins at logic high when no key is pressed. When the system powers on, the microcontroller first configures the ports. Analog functions are disabled so that all pins work properly as digital inputs and outputs. Port B is configured as output for the LCD. Port D is split so that the lower 4 bits are outputs for the keypad rows and the upper 4 bits are inputs for the keypad columns. Port C is configured as output to drive the relay, LEDs, and buzzer. After initialization, the LCD displays the message Enter Password. At this point, the system waits for the user to press keys on the keypad. The keypad scanning works by driving one row low at a time while keeping all other rows high. The microcontroller then reads the column pins. If a key is pressed, the low row is connected internally to one of the column lines, pulling that column low. By checking which row is active and which column goes low, the microcontroller can determine exactly which key was pressed. In the code, the keypad layout is stored in a 2-dimensional array. This array maps each row and column position to the corresponding character on the keypad. When a key press is detected, the row and column numbers are used to look up the correct character and return it to the main program. To avoid multiple detections from a single key press, the code waits until the key is released before continuing. This simple technique acts as a debounce and ensures that every press is counted only once. As each key is pressed, the character is stored in an array that holds the entered password. Instead of showing the actual characters on the LCD, the system displays an asterisk for each digit. This hides the password and makes the system look more professional. Once 4 characters have been entered, the program adds a null character at the end of the array. This is necessary because the password is treated as a string. The entered password is then compared with the stored correct password using a string comparison function. If the 2 passwords match, the system displays access granted on the LCD. The green LED turns on, the relay is activated, and the lock opens for a few seconds. After the delay, the relay is turned off and the lock is secured again. If the password does not match, the system displays wrong password. The red LED turns on and the buzzer sounds to indicate that access is denied. After a short delay, the system resets and asks for the password again. The relay is driven through a transistor because the microcontroller cannot supply enough current to energize the relay coil directly. A diode is placed across the relay coil to protect the circuit from voltage spikes when the relay is turned off. In summary, this system demonstrates how a microcontroller can read a matrix keypad, communicate with an LCD, process logic using software, and control external devices like relays and buzzers. It combines both hardware and software concepts into a simple but practical security system. And that is how the PIC16F877A becomes a very strict, very reliable digital gatekeeper.